Welcome to parametric equations and conic sections. So the idea here is we had our variety of conic sections, which we graphed. Parabolas we're really familiar with. Ellipses and hyperbolas had slightly more complicated equations. So again, recall we had three sort of interesting conic sections. So we had three interesting types of conic sections. Namely parabolas, ellipses, and hyperbolas. And it turns out that ellipses and hyperbolas actually have fairly simple parametric equations to define them. So let's first look at an ellipse. So let's consider an ellipse, which is centered at HK. With horizontal radius A, and vertical radius B. Then the ellipse is defined by, or can be defined by, x of t equals a times cosine of t, and then horizontal translation plus h, and y of t equals b sine of t, and then plus the whole vertical translation of k. So our plotting points example was an ellipse. It took this form with h and k equal to 0. For the parametric equations of a hyperbola, we have two different ones depending on whether we have a horizontal or a transverse axis. So for a hyperbola with horizontal transverse axis, which is centered at HK. The curve can be defined by x of t equals plus or minus a secant of t plus h, and y of t equals b tangent of t plus k. So this is our horizontal transverse axis. For a vertical transverse axis, we get x of t is equal to a tangent of t plus h, and y of t equals plus or minus b secant of t plus k. So we get some useful tools that we have for creating parametric equations for a hyperbola as opposed to the rectangular coordinates. Furthermore, the center HK and A and B can be used to define the rectangle used for graphing the hyperbola. In the sort of hyperbola, just like in the rectangular coordinates. So we get, these are essentially the same A's and B's we saw before. Again, we have two separate equations. It's no longer just we switch which is out front, we swap which is secant and which is tangent, depending on which is our transverse axis here. So these are conic sections written using parametric equations. We have one more video for this section, which will cover essentially when a parametric curve is smooth and when it has a corner.